This is the third section on roots of polynomials, and here we're looking at the roots of a quartic equation. So just like previously, we've got these rules which link the roots to the coefficients of x, and we can see that the sum of all of the roots, I'll just copy them down here, so the sum of the roots, so the roots are going to be alpha, beta, gamma and delta. So the first four letters of the Greek alphabet. So these are our four roots of our quartic equation, which means it basically goes up to power 4. So if you've got four roots of our quartic equation, then our coefficients of our quartic is going to be a x to the power 4 plus b x cubed plus c x squared plus dx plus e equals 0. And you can see from the top there that the sum of all the roots, alpha plus beta plus gamma plus delta, is equal to negative b over a. You can also see that the product pairs, so alpha beta plus alpha gamma, so all the different combinations of pairs you could make, alpha delta, and then beta gamma plus beta delta plus alpha delta, that's always going to be equal to c over a. So that's the product pairs. So now we've got these product triplets. In other words, when you multiply three of the roots together, and there are actually four different combinations: alpha, beta, gamma, alpha, beta, delta, alpha, gamma, delta, and then beta, gamma, delta, and that's always equal to negative d over a. And lastly, we have the product of all of the roots, alpha, beta, gamma, delta, is e over a. Now, like previously, what we might want to do is divide everything through by a, so that we have this x to the power 4 plus b over a x cubed plus c over a x squared plus d over a x plus e over a equals 0. And if you look, what you'll see is, okay, I've got b over a, well, I've got negative b over a there, c over a, well, I have c over a here, d over a there, I have d over a, well, negative d over a there, and then lastly I have e over a here, and I have e over a here. So if we are careful about the signs, we can find all the coefficients by looking at these rules to do the roots, and if necessary, if those coefficients aren't whole numbers, we can multiply back up to make them integers. Okay, before we start this question, just one or two things that just going to make writing out some of these sums here a bit easier. So this first one here, rather than having to write that out all the time, we can just write sum alpha. That means the sum of all the roots. So we can write sum alpha equals negative b over a. Yeah, that's fine, rather than writing all of those out. It's more useful, I suppose, when you get to the second and third one. So when we get to this one here, rather than writing all of those equal c over a, we can write that the sum of alpha beta equals c over a. That basically means the sum of all of those pairs. And the last one down here, whoops, we have a highlighter. Yeah, rather than writing all of that equals negative d over a, we can write the sum of alpha, beta, gamma equals negative d over a. So that saves us having to write out the whole long thing. That's shorthand for writing those sums. So this question here, we've got a quartic equation where we actually have a couple of roots which are complex roots, and they're conjugates, and we've got a couple of expressions we need to prove. So the first thing that we need to do, we're going to write down the values of the coefficients first. A is 1, B is 2, C is P, D is Q, and E is negative 60. And we're going to write down the value of these two roots we know. So gamma is negative 2 plus 4i, and delta is its conjugate, so that's negative 2 minus 4i. So we're now ready to start part A. It says that show alpha plus beta minus 2 equals 0. Now, I only know A, D, and E. So I need expressions that only use A, D, and E. So I can't make use of this or this. Yeah, because the P and Q aren't known yet. And because I've got alpha plus beta, I'm going to be using the first expression, which I can write as sum of alpha. And I know the sum of alpha is equal to negative b over a. So sum alpha I can write down as the sum of the roots, alpha plus beta, plus the other two roots, negative 2 plus 4i, plus negative 2 minus 4i. That equals negative b over a. So that's negative 2 over 1, which is negative 2. This tidies up to give me alpha plus beta. Now I will get negative 4. The 4i's will cancel out, give me negative 2. So if I add 2 to both sides, I get that alpha plus beta minus 2 equals 0. Whoops, mine equals in the wrong place. Equals 0 as required. Okay, this is the first one. Now if I look at the second expression, so if I look at this one here, which I'm trying to prove, I have to use the bottom expression for the reason I said above. I've got E, I've got A, but I haven't got D or C. So we're going to use the bottom expression. So the bottom expression is that alpha, beta, gamma, delta is equal to E over A. So what exactly is that? So it's going to be alpha, beta times by gamma, negative 2 plus 4i, times by negative 2 minus 4i equals E over A, which is going to be negative 60 over 1, which is negative 60. Let's multiply out the brackets. So we'll have alpha, beta. Now we can use the quick way of multiplying out these brackets, which is the sum of two squares. So you'll basically get negative 2 squared plus 4 squared equals negative 60. So that's basically 4 plus 16, 20. So that gives me 20 alpha beta equals negative 60. Divide both sides by 20, we get alpha beta equals negative 3, and then we can move the 3 over and get alpha beta plus 3 equals 0. There's a second statement proved. And in part B it says hence find all the roots of the quadratic equation and the values of P and Q. So we're going to start by solving these equations here and here. We're going to solve them simultaneously to find out what alpha and beta are. Once we know what alpha and beta are, we know all four roots, we can then use that and the expressions that we have to work out what the values of P and Q are, those coefficients. Right, so if I take the, let's see, the first equation, And if I write it as alpha equals 2 minus beta, I'm going to substitute that into the second equation. So I will get 2 minus beta times by beta plus 3 equals 0. So that will give me 2 beta minus beta squared plus 3 equals 0. Times everything by -1, so I get beta squared minus 2 beta minus 3 equals 0. Now that factorizes, hopefully, so I can find out what beta is. So beta, I think it's going to be -3 plus 1. That seems to work. So that's beta equals 3, beta equals -1. Now, if beta is 3, what value of alpha do I get? I'll get -1 for alpha. And when beta is -1, so I'm plugging this into the first one, so I'll get alpha minus 1 minus 2. So alpha minus 3 equals 0. That means that alpha is 3. Right, so we're going to start by finding P, I think. So P is the coefficient of x squared, which is C. So that's C over A. So we're going to use the sum of alpha beta equals C over A to work out what C is. We know A is 1. So the sum of alpha beta, basically we need to multiply together all of these roots. And I'm just going to write them at the top here so they're nice and clear. Alpha equals, I'm going to choose the one where alpha is 1 and beta is 3. I could do it the other way around because it's the same roots, basically the other way around. Gamma is -2 plus 4i. And delta is -2 minus 4i. Just got them there so they're nice and clear. Right, so we've got all these pairs to multiply together. Alpha beta is going to be, I'm going to try and do as much as we can of this in our head. -3 alpha beta. Alpha gamma, -1 times by -2i plus 4i. That's going to be plus 2 minus 4i. Right, alpha delta. Right, so that becomes plus 2 plus 4i. Where are we now? Beta gamma. So that gets times by 3, so we end up with -6 plus 12i. Beta delta, -6. No, hold on, I need to go back, don't I? Let's go back to beta delta, -6 plus 12i. I put 2, should be 12. Now beta delta, -6 minus 12i. And the last one, delta gamma, that's going to be -2 plus 4i times by -2 minus 4i. Now we've worked that out before. That was 20. So I can put plus 20. I worked that out before. Right. And all of that is C over A, which is basically just C. So any stuff that cancels out, right, that and that cancel out, the 12s. Anything else, those i's cancel out there. Right, so all I'm left with is -3 plus 2, which is -1. Take away another, add another 2, which is 1. Take away 12, which is going to be -11. And plus 20 is going to be 9. So that means C equals 9. Which means basically if C equals 9, then P equals 9. I'll put a box around that because I'm not working. Then to find Q, I'm going to do the sum of alpha, beta, gamma, because Q is the blue highlighted one where I've got the D, and so that equals -D over A. A is 1, so basically it's going to give me -D, so whatever sign I get, I need to reverse it. So we need to do the pairs. Right, this is going to be fun. Alpha, beta, gamma. So it's basically -3 times by -2 plus 4i. So -3 times by that will give me 6 minus 12i. So that's the first 3. I've only got 4 of these to do, which isn't too bad. Alpha, beta, delta. So that's going to be -3 times by -2 minus 4i. So if I times those by -3, I'm going to get plus 6 plus 12i. Alpha, delta, gamma. Right, so I know that delta gamma is 20, and I'm times that by -1, so it's going to be -20. Then beta delta gamma, so I know that delta gamma again is 20. I've already worked that out. So I'm timesing that by 3. So that's going to be 20 times 3 is 60. Right, before I start adding stuff, is there anything that cancels out? Well, the 12 i's go. So what have I got? 6 plus 6, 12. 12 minus 20 is -8. And -8 plus 60 is going to be 52. Okay, this is what -D over A is. Okay, what does that mean? That means that D is 52, which means that Q is 52. So you can see on this question, there's lots and lots of multiplying out stuff. Sorry, -52, isn't it? D, -D, sorry. Even I made a mistake there. So that should be -52. So you can see there's loads of multiplying out. There's loads of places where you could make an error if you are not careful. Okay, you should now be able to do exercise 4C on pages 60 to 61. I'm just going to write out the rules for the roots here, so you've got them if you need them. Alpha plus beta plus gamma plus delta is -B over A, which we can just write as the sum of alpha. Alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta is C over A, which we can write as the sum of alpha beta. Then the free roots, alpha beta gamma plus alpha beta delta. You'll see it here, it's just basically every combination, plus alpha delta, alpha gamma delta plus beta gamma delta is -D over A, which we can write as the sum of alpha beta gamma And then the last one is just all four of them: alpha, beta, delta, alpha, beta, gamma, delta is E over A. And remember what we do, if we divide everything by A, we'll get x to the 4 plus B over A x cubed plus C over A x squared plus D over A x plus E over A equals 0. And as we said before, these things match up, don't they? B over A. Okay, there it is. C over A. There it is. D over A. There it is. E over A. There it is.